This conference will now be recorded.
Our AI creation and how to secure our AI and all of the stuff about our machine learning and so on, we need to have a basics. So if you are absolute beginner, what I will recommend you is to start from first two sections. And the first section is all about basic terminology in our cybersecurity, like CIA, triad, different cryptography, and so on. So all of this stuff is going to be explained over here. And in the second section, you will get a basic Python. So you will learn how to create a code using Python. And then we will be able to move forward to our AI. So this video, we are going to talk about our CIA triad. And CIA triad stands for confidentiality, integrity, and availability. So let's see what each of them means. The first one is confidentiality. So confidentiality ensures that information is accessible only to authorized individuals or systems. So the goal is to prevent unauthorized disclosure of sensitive information. And that's absolutely important for our course. For example, a bank encrypts customer account data, so even if the database is stolen, attackers cannot read it. So encryption is the process of converting readable data, which we call plain text, into an unreadable format, which is ciphertext, using a cryptographic algorithm and key. We will talk about cryptography a bit later in this section. So a small example over here, if an attacker steals database, without decryption key, the data is unreadable. This maintains our confidentiality even during a breach. So for example, you have your database, you have your ID, username, password, email, and credit card. So all of this is plain text. We can read it. We can read user one. His password is my password 123. His email is user1 example.com. And credit card, we can read its credit card. And the same with our admin and his password and his personal details. So that's the huge problem for us. But if we are going to encrypt this, so from plain text, we will transfer this text into ciphertext, then we will not be able to read its password, for example, in plain text. So for example, we will be able to read his username, like user1 and admin, but the password, as you can see, is now not readable. So this is the edge. This actually is converted from plain text into unreadable ciphertext. We still can read email, but we cannot read credit card because it's encrypted. And this kind of security is fully ensured by our confidentiality, because if our attacker, for example, gets access to the database, and if our database is not encrypted, then he has access to each of the values that are stored inside of this database. But if our database is encrypted, even if he got the access to our database, we will not be able to get any useful information from there. And that's what confidentiality is for. So let's see what is integrity and availability. I'll be talking about our confidentiality and integrity and the main difference between them. Now it's time for availability. Availability ensures that systems, services, and data are available when needed by authorized users. So the goal is to prevent downtime or delays in accessing data or services. For example, an e-commerce website uses multiple servers, so it remains online during high traffic because traffic is distributed across multiple systems. So how we can achieve it? Redundancy, backups, DDoS protection, and disaster recovery plans. So the thing is, let's imagine that we have our users, we have our website, and we have our servers. The thing is, when one user sends the request, it is going to be distributed only to one system because that's not a huge amount of requests to our website. So the thing is, it will be able to process this request. But when we have a huge amount of users, for example, thousands or hundreds thousands of users and hundreds or millions of requests per second to our website, we have the small probability of downtime. So if we have only one server that actually processes all those millions of requests per second, basically it is going to be overwhelmed, and then our website will become not accessible, and that's not what we need, right? The thing is, if we have millions of requests per second, we need to distribute traffic not only to one server, but across multiple servers. Now, when we have, for example, 100,000 of users, these requests are going to be distributed to 3 different servers or to 30 different servers. And those servers are going to be able to work together to actually process all of the requests and to ensure that our website works. Because let's take a Nike. It has thousands and hundred thousands of customers per day, and they make a huge amount of requests. They pay lots of money, so Nike actually makes lots of money from online shopping. And if their website is going to be down for even like a few hours, they will lose millions of dollars. So availability ensures that our service is always up and is always accessible by our user. That will ensure that we do not lose money and our services are accessible. So once again, we need to ensure that our requests, if there are a huge amount of requests, they are going to be distributed across different platforms. So they will be able to process all of those requests without any, even a millisecond of downtime. In previous videos, we discussed CIA threat and its importance to cybersecurity. So now, before we will start the main course, we need to understand a bit of networking. So we will discuss what is LAN, WAN, and VLAN. So the first one is LAN, and LAN stands for Local Area Network. This is small geographic area like office, home, or school. This is high speed and private ownership. For example, your office Wi-Fi network. So let's say that you have your homework network, and that's how your LAN looks like. You have your router, and you have devices that are connected to this router, and you have access to external networks like Netflix, YouTube, and so on. All of this stuff is local area network because it's so small. For example, inside of it, you can have a few phones like printer, laptop, PC, or TV, and so on. This is your local area network. The main difference between WAN is that WAN is wide area network, and this is large geographic coverage like city, country, and global. So often is public infrastructure like internet. So for example, WAN can be the internet itself. So important note, a WAN is a collection of interconnected networks that span large distances, often using public infrastructure plus private based links. And the main difference from LAN and WAN, VLAN is that VLAN is virtual LAN. So it is a logic segmentation inside a LAN. Devices can be grouped virtually even if not physically in the same place. So for example, we have our school, and basically we will group our teachers' PCs and students' PCs. So basically our teachers are going to be in the same network, and students are going to be in the same network, but in different groups of those networks. And basically our teachers will be isolated from our students virtually and in the network, but not physically. So that's the basics of networks that you need to know for this course. We will not go into each of them and deep into networking because you are not required to know a lot about networking, just the basics now. Dive deep into our AI course, we need to know what is principle of least privilege because we will talk a lot about this principle. The principle of least privilege means that every user, application, and system process should have only the minimum access necessary to perform their legitimate duties and nothing more. So, in other words, we can say we will give people the keys only to the doors they need to open and nothing else. The goal of POLP is to reduce risk by limiting what users and systems can do. If an account is hacked or a user makes a mistake, the damage stays contained because they don't have access to everything. So basically, let's say that we have a log file, and this log file has permissions like edit, write, and read. So if our attacker hacks into the system and is able to get the same permissions. So basically, what I'm trying to say, our attacker will have the same permissions as this file. So he will have access to edit this file, write this file, and read this file. That's just an example, and don't think about this globally. But basically, what our principle of least privilege will ensure, we keep the permissions that are necessary to complete its job. So it should have read-only permissions. So other systems like CM will be able to access and analyze this file, but we cannot modify any data inside. And we will see this a bit later in these PowerPoint presentations. So basically what I'm trying to say, we will delete edit permissions and write permissions, but we will leave only read permissions. And that's when attacker will try to access this file, he will be able to read the data inside of this file, but he will not be able to edit any data or write into this file any data. So we'll ensure that our data inside of our log file or any files is not be able to change. Before we will create any security tools that are using machine learning for decision making, we need to understand what security and what type of security tools are there. And the first one is firewall, then IDS, IPS, EDR, and also CM. So let's see each of them in details. The firewall, a firewall is the first line of defense. It filters incoming and outgoing traffic based on predefined rules. It is also inline, which means that all traffic passes through it, and that's how it looks like. So our firewall works together with our router. So before our traffic from the internet is going to penetrate into our network, local network, it is going to go through the firewall, and firewall is going to decide, do I allow this traffic or do I block this traffic? Then we have IDS, which stands for Intrusion Detection System, and it monitors network traffic without interfering, detecting suspicious or malicious activity. It is also outbound or not inline, which means that traffic does not pass through it, but it works in the way that our traffic that goes into our local network is going to be mirrored or copied and sent to our intrusion detection system or network intrusion detection system, where it is going to be analyzed, and then if something suspicious is there, it is going to raise an alert. Then we have IPS, which is intrusion prevention system, and this system detects and actively prevents malicious activity in real time. It is also inline, so it sits directly in the traffic path. So it is similar to our IDS, but one difference is that it is inline and also it is able to block, not only alert. So basically our traffic is going to be analyzed, and then if something suspicious happens, it is going to raise the alert, and also it is going to be able to block this traffic. EDR, and it EDR stands for Endpoint Detection and Response, and this is a system that monitors and defends end user devices and servers against malware, ransomware, and advanced threats. It is installed on endpoints or host level, not in network flow. So it looks like that. So imagine that it is your antivirus. Basically, it is installed on your system. And if there is something like suspicious file, then it is going to detect this and raise the alert, and also will be able to prevent installation or delete this file from your system. The last one is CM, or Security Information and Event Management. And this is a centralized system for collecting, correlating, and analyzing security events and logs across the network. So it works in the way that your firewalls, network intrusion detection system, endpoint detection and response, and all of these security systems are going to generate the logs. All of those logs are going to be passed into our security information and event management system, where it is going to be analyzed, and if something suspicious is detected, it is going to raise an alert. And then our cybersecurity specialists are going to mitigate this incident. Next important bit that we need to discuss is cryptography. And it is not going to be a huge discussion about cryptography, but only basics like symmetric encryption and asymmetric encryption. So symmetric encryption uses one single key for both encryption and decryption. So our sender and receiver must share the same secret key. And the important note that key is very important part in encryption because it relies on it. So basically, when we have our sender, and for example, you want to send your file to another person, you are going to use a key to encrypt your file. So this key is going to encrypt your file, and then this file, encrypted file with this key, is going to be sent to your person that you want to send this file. And this person, in case to read this file, open this file and read this file, is going to use the same key that was used to encrypt this file to decrypt this file. And then this person is going to be able to read this file. So basically, once again, symmetric encryption means that we use one single key for both encryption and decryption. And the main difference between asymmetric key encryption, it uses two different keys. Public key that is used to encrypt can be shared with everyone, and private key is used to decrypt, so it's supposed to be kept secretly. So this system is also called public key cryptography. So let's say we have a Bob, and Bob wants to send the file to Alice. Bob is going to take the public key of Alice and encrypt files that he wants to send to Alice with her public key. This file will become encrypted. Alice is going to receive this file, and then Alice is going to use her private key to decrypt this file. Just because her public key was used to encrypt, she can use her private key to decrypt. And once again, public key can see everyone, but private key can see only you, and it's supposed to be available only to you because it is used for decryption. And then she is going to be able to decrypt and to basically read and open this file. Before we will start, we need to install Python and Visual Studio Code. And let's see how we can do that. So first of all, we will install our Python. To install Python, we will simply go to the Google and bring install Python. And as you can see, the first link is to download Python. We will click on it, then click on download Python, and it will start the download for us. So the thing is, we need to click on it, and we will get our installation wizard. So now, before we will click on something, we need to click add Python Z to the path. So that's what we is required. So then we will click install now, and it will start installation for us. While it's installing our Python, we will install our Visual Studio Code. So to install our Visual Studio Code, we will use VS Code, install, and download Visual Studio Code. As you can see, you can download for the Windows, Linux, and Mac. In my scenario, I will install it for Windows, and it will start installation for us. So it finished installation for me. I will click on it, and now we will accept the agreement. Then we will click next, next, add to the path, yep, and create a desktop icon. Next, and install. So now we will wait until all of them are finished. So it fully finished installation for me for the Visual Studio Code and the Python. So I will close the Windows Python. And now we have our Visual Studio Code, but that's not everything that we need. First of all, we will go to the extensions and we will find our Python extension. So now we will click, I have it installed, but the thing is I will uninstall it and you need to click on install it. And also Python debugger, but it should install it automatically with Python 3. If it's not, then try to install it, right? Then we have a code runner, which is a what you need to run your code, and you can also install it. In my scenario, I have everything installed. So now, if I will go to search and CMD, if Python was installed correctly, I need to type Python version, and I need to see that, as you can see, the version of Python is 3.13.7. In your scenario, it may be a different version, right? At this moment, it is the newest version of Python, right? To create something, we will create a folder. Let's say, for example, Python, and we will open folder. Then we will go to desktop, Python, and then select folder. Yes, I trust these authors. And then to create something, we will create a new file. I will name it main.py. And if I will use something like print hello there, and if I will click on run the code, it's supposed to run it. And actually, I didn't save it. To save it, we need to go to file, save, and then run it again. And as you can see, we got our output. The thing is, if you don't like how it looks like, you also can go to the extensions and build a theme. That's the best theme that actually I use, and you can select your color which you prefer, right? And this will make your code a bit better. Interpretation and compilation. Programming is not just writing code. Writing code is like writing a recipe in your own language. And computers don't understand Python, C, or Java directly. They understand machine code, which is actually the only one language they can process and understand. To bridge the gap, we need a translator. That translator can either compile everything in advance, which means a single executable file the computer can run, for example, your game, but you will double click on it, it will execute some of the processes and some of the codes, and actually your game will start. Interpret each instruction as the program runs, which means step-by-step execution. So without one of these processes, the computer literally cannot understand what we wrote and what we need. Compilation translates human-readable source code into a lower level form, so which is machine code, or in Python's case, we call it bytecode. So it also checks for syntax errors, so the grammar of the language. If syntax is broken, compilation fails, and the code never runs. Interpretation is a bit different. So it takes the already compiled code, or in Python it's called bytecode, and executes it line by line. At this stage, the program can still fail if something is semantically wrong. For example, dividing by zero, we cannot divide by zero, or wrong type operations. So let's see a small example about all of those stages. So let's say we have a user that wants to execute his code, and first of all, we need to translate this code into a machine code, which is the only language computers can understand and process, right? So the first stage is a compilation phase, where our code is translated to machine code, and also it is checked for any errors or syntax errors, right? Then after this phase, we go to interpretation phase, which executes code that was compiled, and also, as we already know, it still can process some of the errors if they occur. So we will see all of this stuff in our hands-on along the course. So I will see you in the next video. A bit later in the course, so if you don't understand it right now, don't worry. But for output, print function is responsible. So to create something that is going to be printed to our terminal, we will use print function and then our brackets. And inside of those brackets, you can use single quotes or you can use double quotes. So inside of those double quotes, you will put anything that you want to see inside of your terminal. So let's say I will use hello there. And to save something, you can go to File and Save. And as you can see, you can use a shortcuts Ctrl plus S if it's Windows, right? So to run your code, you can go ahead and click on Run Code. And as you can see, now we can see our output inside of our syntax and semantics. So syntax means a form and shape of our code. So those are rules that decide how code must look. So it covers grammar, punctuation, indentation, and keyword order. So it is checked before execution during our compilation phase. If it's wrong, Python will raise syntax error or indentation error and won't run code at all. So let's say that we have a user and he wants to run the code. So first of all, we will go through the process of compilation, where we will translate our code into machine code, and also we will check some of the errors if there is some. But if there is some error, it will not go to our second phase, which is our interpretation phase. So as you can see, you have syntax error, and this means we will not go to the execution of the code. Semantics means meaning and behavior of our code. So what the code actually does once syntax is correct. So for semantics, interpreter is responsible. So it happens during our interpretation phase after our compilation phase. So if our compilation phase was good, there wasn't any errors, and we can go further to our interpretation phase. Interpretation phase will still check for some semantics errors, right? So if wrong, code may raise a runtime error, for example, type error, name error, or zero division error, or it will run but produce a logic bug, which will actually mean a wrong result and no. So let's see a quick example. So in previous video, we practiced our print, so to see some output to our terminal. So let's practice some semantics and syntax errors. So we can simply forget to put a one bracket by the end of our print function. And if we will forget about this and we will save our file and run this code, as you can see, we got our syntax error. also it says that bracket was never closed. Also, if I will forget to put our double quote by the end of our string and run the code, as you can see, I will get a syntax error, unterminated string literal. So this means we didn't finish our string, we didn't close our string, right? So we forgot about the quote. So about data types and strings and literals, we will talk a bit later in the course. So the main thing you need to understand that when you will get something, like you will have syntax error, your code will not produce the output or the results that you will expect, right? So, but that's all about a syntax error. Let's see our semantics error. Let's say that everything is fine and the logic of the code is perfect. So as you can see, we don't have any syntax errors. So we have our double brackets, we have our double quotes, everything is inside of these quotes. But let's say that we will try to add something that is not expected by our Python. So let's say that we will try to add a string to a number or integer. Don't worry, I understand that maybe you are not recognized with strings and integers. We will talk about those data types a bit later in the course, but that's only for demonstration. So as you can see, those are a different data types, right? And if I will try to add 5 to a string, we will actually, it is going to be executed, but as you can see, we didn't get any outputs. Let me try to run this in our terminal. And as you can see, it says can only concatenate strings, not integers. So we cannot actually add our integer to a string. But that's not what you need to understand right now. That's only for demonstration of semantics. And we will talk about this a bit deeper later in the course. I will see you in the next video. Comments are an important part of the Python. To use a single line comment, we can use our hashtag. And this means that everything that goes after this hashtag is ignored by Python. And this is our simple example over here. You will see this example in the next video. Also, we have multi-line comments, and to use them, we will use triple quotes. So, and this is our example also. So let's see a hands-on experience with comments. So let's use some comments. To use our single line comment, we will use a hashtag, and let's say this is comment. So if we will run it, as you can see, we got only hello there. That's because everything that goes after our hashtag is fully ignored by Python. But it also means if we use hashtag, it is not going to be ignored after the next line. So if I will put some text in the next line, as you can see, it will give us some invalid syntax because Python doesn't understand what I mean under those words, right? And to deal with it, we can use a multi-line comment, right? To use our multi-line comment, as you remember from your theory, we can use triple quotes. So 1, 2, and 3. That's too much for me. And I can put inside everything that I want, but first of all, I will finish it. So to use our multi-line, I can actually use triple quote and triple quote on the end. And I will say, I am Alex. Then in the next line, 1, 2, 3, 4, 5. And this is also common, and so on. As you can see, we use 3 lines and it's still common. So if I will run it, as you can see, we got only hello there. So, and that's actually what we were expecting to get. That's because we are using triple quote, which means that we can use a multi-line comment. So I will see you in the next video. literals. A literal is a fixed value written directly in the code. Fixed value does not change unless the programmer edits it. So the examples are a numbers, strings, and also booleans. So let's see in details what each means. So integer is a whole number, positive or negative, without a decimal point. So examples are, for example, 0, 10, minus 15, 20, 25. So those are a whole numbers. Those are just a general numbers that we can use every day. So if we will use 3.15, this is not integer anymore because this is not a whole number. And remember that integer is a whole number without a decimal point. Float is a numbers with a decimal point. So examples are 3.14 minus 0.5, 2.0. So as you can see, all of those numbers have a decimal point. So, and it is used for measurements or anything that is not whole. Strings, a sequence of characters such as letters, digits, symbols, or spaces, and it is always inside a quote. So we can use a single quote or a double quote. So examples, we can use Python in double quotes, a character in single quotes, and 1 to 3 in double quotes. Then we have a boolean. So boolean is a only two possible values. So it contains only two possible values, true or false, used for logic and decision making. So for example, 5 is greater than 2. It is true because in maths 5 is greater than 2. 2 is less than 3. That is also true because 3 is greater than 2. 2 is less than 1, it is false because 1 is not greater than 2. And that's all about the booleans. It's only true or false. So also we have a special none. So it represents nothing, no value, or empty placeholder. Often is used to show that a variable has no value yet. So for example, result is equal to none. So there is not result and no value for now. So let's practice our integers. So integer is a whole number without decimal point. So basically, how do we print something like a number? So integer is just a number, just a general number that you can use every day. So for example, 12. So I will save this and I will run it. And as you can see, we got our output. We can use 14 and it also works for us. So that is our integer, right? So I will leave the comment over here, integer. So after that, we have our float, and float is a number with decimal point. So we will use print and, for example, 13.4. And if we will run it, as you can see, we got 14, which is our integer, and we got 13.4, which is our float. And to verify if it actually is a integer or float, we can use a type. So we will use print, and inside of brackets, we will use, let me just delete it, we will use type, and then after this type, I will use brackets again, and inside of these brackets, I will put our value, for example, 13.5. So if I will run it, as you can see, it says class float for our second number. And if I will use the same thing over here, we need to get actually integer. So as you can see, int is shorter for integer, and the second, so the first one is integer, and the second one is float, right? That's how we can verify our data type. So let's use our string. So the string is simply the characters, sequence of characters inside of our quotes, single quotes or double quotes. It doesn't matter. For example, Alex, right? So if I will run it, I will get this, and also we can verify this by using type. We will run it, and as you can see, it says that it is string. So the next one is our boolean. So boolean is true or false. It has only two values, true or false. And let's say true, and if we will run it, as you can see, bool, which is shorter for boolean. And the last one that we were discussing is a none. So if I will use type and none, and if I will run it, as you can see, it says non-type because it's empty placeholder. So that's it about integer, float, string, boolean, and non-special none. And we will see in the next video what are variables. And the most important part in Python are variables. So a variable is a name that refers to a value stored in memory. You assign values using is equal. Examples, age is equal to 17. So basically you store number 17 or value 17 inside of our age. Name is equal to Alice, and Alice now is stored inside of name. Student is equal to true, and true is now stored inside of student. So this is basically a temporary storage for your values, and value are after is equal. So now we can use those to print our values. We can use our variable to print the value that is stored inside of this variable. So print age, and it will print the value 17. Print name and print student. We will see all of this stuff in hands-on, so don't worry about this right now. So let's practice our variables. First of all, I will delete everything and I will clear our output terminal. So variables can store values inside. So let's say that I want to store my age inside of this variable. So let's say that I am, for example, 20 years old. So basically what is going on behind this theme, we have the integer, which is our 20, and now instead of just printing, for example, print 20, we can store this 20 inside of our variable, and then if we have a huge code, we can use this variable to actually print or do some maths with our numbers or with our value that is stored inside. So basically, we are storing this 20 inside of our variable, and that's really important to remember. So if I will want to print this value, I will just simply use the name of the variable because we are storing this value inside of this variable. So I will use age, and if I will run it, as you can see, I got our output, which is 20. So, and I can do the same thing with strings, booleans, and any data types that you prefer. For example, name, and we will store the name of, for example, our friend inside of this variable. So let's say Alex. So if I will want to print this name, this value, I will just use the variable name, which is our name. So if I will run it, as you can see, we got 20 and we got also Alex. Relational operators. So relational operators are used to compare values. They return Boolean, which is true or false. So those are our relational operators that we can use. So the first one is double equal. So it is going to call equal to, and it checks if both sides are the same value. So for example, we have 5 on the first side and 5 on the another side. So if we want to check if those two values are the same, we will use double equal. The next one is not equal to, and it is important to know that exclamation mark is not means actually not, so not equal to, and it checks if two values are different. So, for example, if our name is not equal to Alex, right? So then we have greater than, less than, greater than or equal to, less than, excuse me, or equal to. So as you can see, example is over here. 5 is equal to 5. It is going to be true because our left value is the same value as on the right side. 5 is not equal to 3. It is going to be also true because once again, it checks if the two values are different, and they are different. 5 is different from 3, right? Then we have 5 is greater than 3. It is going to be true because 5 is greater than 3. 5 is less than 3. It is going to be false because 5 is greater than 3. 5 is greater or equal to 5. It's going to be true. Why? Because first of all, it will check if it actually, if our left side is greater than right side. It is not greater than our right side, so it will go to the equal. And if our left side is equal to right side, it is going to be true because actually 5 is equal to 5, right? Then we have 3 is less or equal to 5. It is true because 3 is less than 5. Is responsible for output, and you already saw it in our examples. So basic usage of print function is a print hello world. So we use our double brackets and our double quotes. It can be a double quotes or single quotes. And all this does, it prints the text or values to the screen. So it also can print a multiple values to the screen. So for example, we have a print and we have our string, my age is, and then after comma, we will print our second value, which is 17, and which is our integer. So this is the things that you didn't see about output in Python. So by default, values are separated by a space, but you can change this by using a sep parameter or separate. So it will change what separates items. So for example, we will print A, B, C, and separator, which is sep, is equal to minus. So our output will look like that. So A minus B minus C. Also, end parameter changes what happens at the end of the line. And by default, it creates a new line. And as you can see, we use a slash n for the new. So let's practice our output. So to output something to the terminal, you already know, we can use print and we can put something inside. If we will run, it is going to be printed and read our terminal. But the thing is that we didn't practice and that we didn't know. For example, if we want to put or print multiple values, we can do this by using comments. So let's say I am, and then after comma, I will put my second values that I want to print to the terminal, Alex, and also I can print third value, and let's say I am, and then first value, let's say 20 years old. So if I will save this all and print, as you can see, it printed all of this stuff to the terminal. So I am Alex and I am 20. So all of those are different values. So we have first value, second value, third value, and fourth value. And all of them are separated by spaces. So if I will delete those spaces inside of this quotes and run it, still, as you can see, those are separated by commas. not commas, excuse me, by spaces. We can change this by using a sep. So sep is equal, and let's say that I want to use minuses. So as you can see, I am minus Alex minus I am and minus 20. You can wonder why don't we have a minuses over here? That's because those are not a spaces that are created by default. Those are spaces that we are creating inside of our value. So those spaces will only actually separate our values. So anything that is between our values, right? Not that is inside of our values. That's really important to remember. So one more thing, by default, if you remember from the theory, we have and that is equal to something. By default, it creates a new line. As you can see, we have this blank space over here. So we have our line, that a new line. That's because by default it creates a new line. But we can change it. For example, let's say I don't want a new line, I want just a dot by the end of this. So if I will run it, as you can see, we don't have any new lines. So we don't have any black spaces. We have only a dot by the end. So we can compare those answers. As you can see, here we have actually two lines, one, two, and here we have only one line, but the dot by the end. So that's it for now. I will see you next video. So let's now talk about